very good morning to all our audience. Today we are very honored to have a very distinguished guest. It's Professor Roger Bilham. Roger is a professor at the University of Colorado. He teaches geology, and very interestingly, he works on earthquakes. And Roger has been visiting Pakistan for a very long time, and he has a lot of interest working in the Indus Delta and the coast of Pakistan, and also the mountains. And we are very honored that today he has graced us with his presence. So with that, we will welcome Roger in the conversation. Thank you, Roger, for taking the time out to be with us.
It's nice to be here. Thank you for having me.
Roger, tell us about what interests you in Pakistan and what brings you here regularly, and what's the connection?
Well, okay. I'm a seismologist at heart, and my special interest is in using geodesy, basically GPS and triangulation methods, to measure deformation, the movements of Pakistan. And of course, the interesting thing is that Pakistan is moving northwards as a result of plate tectonics. And as a result, the edge of Pakistan is grinding against Balochistan, the southern tip of Asia, producing occasional very large earthquakes, damaging earthquakes, 7.5, 8 magnitude. And it's really the forecast of these future earthquakes that is of great interest to everybody. We get a very loose idea of that from measuring geodesy, but every little piece of information we can measure contributes to our ability to not to predict, but to forecast earthquakes. That's really what brought me here. And we've been working with NED University for several years now, and with the University of Balochistan, measuring GPS points. And one stunning result, very unexpected, is that nearly every point we measure is subsiding, is going down. In other words, we're after the horizontal movements, but we're finding that there is local subsidence in every city that we visit, or where these instruments are operating. And this subsidence is man-made. It's nothing to do with plate tectonics. It's entirely due to the thirsty nation that is Pakistan. You are basically pumping water out of the ground, and as a result, the surface is subsiding. And over the past something like 3 years, this realization has now driven us to ask the question, where is this going to impact Pakistan the most? And the answer is that the Indus Delta is going to be hit below the belt. This is what's heading for the Indus Delta. It's already starting. Subsidence is occurring at such a rate that the shoreline is retreating northwards. And I'm sure you know more about this than I do, because NIO has a very large project there. But for us to discover this from the GPS signal is quite a surprise.
Thanks, Roger, for that answer. But this conversation is going to be heard by people who are not geologists and not scientists. Could you tell us a little bit about what is subsidence and why it's important for us?
Yes. Well, okay.
And why should we even be bothered about it?
Okay. So for most of the evolution of Homo sapiens, the Earth's surface has been considered to be a flat surface that neither moves or changes in any way. It's stable. This is home. It's flat. We can build houses on it. Well, when you have earthquakes, the surface is no longer stable. It shakes. And it shakes up and down and sideways. And that's a transient effect that we understand, we can study and quantify very easily. But there's another form of instability that is not natural. It's the instability caused by removing water from underground. it sounds innocent enough to drill a well and suck out the water. But what happens is, as you suck the water out, the water underground is in some ways supporting the surface. So with the loss of pressure underground supporting the surface sinks. We call that subsidence, and it's caused by compaction of the soils and sediments above or within the layer that you're sucking the water from. The problem in Pakistan, and in fact in every part of the world, is that fresh water is in enormous demand. The demand is year round, but the supply is intermittent and usually insufficient. There is not sufficient fresh water. And when it comes in overwhelming quantities, and the floods that you've experienced recently, I have no need to remind you about. So when there are no floods and it's dry, during the dry season, it is impossible to resist the compulsion to suck the water out of the ground because it's there. But it comes with this penalty that the ground above the reservoir that you're depleting actually sinks. Same for oil extraction as water extraction. But in fact, it's water extraction that's causing most of the problems in Pakistan right now. So why is it a problem? Well, very simple. If you suck sufficiently downwards, you produce a depression, a cone, a cavity, so that when you do have a flood, that fills up with water. You've made an artificial lake, where for the millions of years of Earth's of human evolution, that surface was flat, and it now become a lake. And we're getting ponding in many of our cities as a result of local extraction of water, often not even allowed by the government or unknown to the government. Nobody knows how many wells there are and how much is being sucked out. It's just cheap and easy to do. Drill a hole, suck it out. Don't worry about the consequences. But the consequences are really important, and they affect everybody in the end.
Thanks, Roger, for that elaboration. Could you also tell us a little bit about what a delta is, and why should we be looking at preserving the delta? How important it is for the coastal zones? How important it is for Pakistan?
Right. Okay. So a river is a kind of machine. It eats away at the mountains in the highland, transports the particles of sand and silt down the river, and when it gets to the sea, it suddenly becomes very slow and sluggish, and it can't transport anymore. So it dumps its load there. So the delta is the sort of garbage spot, the dumping ground of everything the river has been carrying. And since the time of Alexander the Great, the delta has been moving southward. We know that he had his ships way upstream. It's been moving southward, and until about 1850, it was still advancing quite fast southward. And it would be, were it not for the construction of dams, which I'll explain in a minute, the delta would now be many, many kilometers south of its current location. Now, there's a kind of equilibrium. You dump sediments in a delta, these sediments are full of water, and they begin to sink as the water comes out. And as you add more sediments every year into the space created by the sinking of the previous year, you have this beautiful equilibrium between incoming sediments and subsidence, compaction. Now, when you construct a dam, what you effectively do is you take the ocean and you place it upstream. You've made an artificial ocean, and the sediment, instead of getting all the way down to the delta, gets dumped into the reservoir. It's a very simple process. Geologists have known about it since day one. It's sort of building blocks of rivers. But when you build a barrage, like the Sukar barrage, you effectively block all the sediments. Tarbela and Mangla have done the same. These are now filling up with sediments that would normally go to the delta. The delta, as a consequence, is starved. And as a result of it being starved, it is sinking, compacting. The sediments are getting squeezed, the water's coming out, the water's going down. Now, the land is going down, sea level is rising. So if sea level is rising in Calcutta, in Karachi, at 10 millimeters a year, more or less global phenomena, the descent of the delta as a result of compaction at 10 millimeters a year means that sea level is effectively rising in the delta twice as fast. That means not only is the delta going down, the shoreline is beginning to retreat northwards. You're losing land. Now, you might say, well, so what? What can you do about it? Well, first of all, how much land are you losing? You can do a simple calculation. Most people know what the area of the cricket stadium is, right? How many cricket stadiums are you losing a year, do you think? You can ask that question. Just do a few calculations. The answer is stunning. Effectively, Pakistan is losing the area of one cricket field per hour, and will do so for the next 70 years. That is an enormous loss of land. And engineers know how to fix it. Okay, the fix isn't simple, it's a challenge. But I think engineers in Pakistan can rise to that challenge. I know they will. I know that you are pushing this kind of a solution as absolutely vital. But it is vital. You cannot afford to lose that amount of agricultural land in the next century because populations are increasing. And the land you're losing is not rubbish. It's agricultural land, which is absolutely vital for Pakistan's future.
Thank you. Thank you for elaborating that and emphasizing more about how important the delta is for us. Tell us that the main river that runs through Pakistan is the river Indus. And we have no other river which runs the entire year, although there are many days that we have hardly any flow through the entire length of the river. So there are many dry days as well in the Indus. But the delta has its own issues, and the sea also tends to intrude. If you leave the space available and there's no fresh water to push the sea back, there's a pretty good chance that the sea would intrude inwards.
Yeah.
If that happens, the sea would probably take the spaces that the fresh water had left for. What are the repercussions that we might face in terms of and Pakistan is an agroeconomy, so like you said, we have a large population to feed as well. So what does it save for us in terms of food security, in terms of water security, in terms of our cities and the populations, the coastal population and the city populations that might be impacted when the seawater intrudes in land?
Saltwater intrusion is in fact, it's not a future problem, it's already there. If you go to parts of the delta, you'll find it covered in an incrustation of salt as a result of water intruding because there's no longer any fresh water holding it back. This is a problem that's been faced, of course, by Holland, and they came up with a fix. They had to have a solution. They had to solve that problem because most of their land was at the time close to sea level. Now, in fact, you have the same problem. And although one can dream up all sorts of different solutions, the simplest one to adopt is to do what the Dutch did. Basically, they constructed a very large dam along the coast to hold back the sea. That alone is insufficient because the dam essentially stops the saltwater from coming in as floods inland, but the saltwater intrusion is still there. In fact, it's exaggerated because of that. So the Dutch then realized there was a solution to that. You simply build another dam inland, and the space between the two dams, there's a huge long dam, 300 kilometers long, two parallel dams, perhaps with roads on, but these dams are made to contain fresh water. So during the floods of the Indus, you allow a lake to form in the space between the two dams. And that lake is a freshwater lake that now infiltrates into the aquifers on the coast, and it acts as an underground dam. And that's what's absolutely essential. And one might say, well, it's impossible to do. No, the Dutch did it. You only have to copy what they did. And the second part of your question was, what are the consequences of not doing something? I think the consequences are terrifying. Essentially, your population is doubling every 20 years. So within the space of 100 years, it's doubled, it's quadrupled, it's gone up by 8, 16 times. It's impossible to believe that you can feed your people without using every inch of agricultural land. You can't afford to lose anything, and you're already losing it. So now is the time to act. I think, I'm confident that I'm working with a bunch of engineers at NED. They can do anything, and all they need is the mandate to do it. And I think NIO knows the problem too. So it's just a matter of getting the problem to the problem solver, and the person that can do that as a politician. And in discussions, I realized that yes, this is an expensive undertaking, but no, it's not really. It's actually an investment, not just for the future, but for the present. The construction of such a magnificent scheme to hold back the waters of the Arabian Sea is something that will produce endless opportunities for local people, for fisheries in the future. I mean, essentially, it is not a losing proposition. It's not expensive. It's essential.
Roger, are you aware of the Mega Delta project? Because in that project, we have 15 major deltas of the world, and most of them are looking at issues and problems which are quite similar to the problems of the Indus Delta. And subsidence is also a common issue in other deltas. Do you think that the solutions that we have, do we have customized solutions for each of those deltas, or do you think there's similarities and we could learn from experiences? If you're looking at the Dutch may be a little bit different in terms of their capacities of in managing such large constructions and engineering projects, etc.
No.
Maybe they have a better scientific pool who can, and it is a matter of survival for that country, Do you think that there are any similar examples in terms of countries where economies are similar or a little bit closer to the Pakistan experience, where we would have the similar kind of pool, so that we don't end up with just another problem, and that we have the right kind of solutions suggested?
Well, okay. First of all, I consider Pakistani engineers every bit as good as Dutch engineers, if not better. I mean, there are more of them, for one thing. I mean, the population of Pakistan is immense. So you have a reserve of talent, and you have the ability to do anything. The second way of looking at this is to say, why do you need to follow the example of other people? Take it, you have your destiny in your hands. You can do it. Show the world what is possible. Don't wait for other people to show you. I think this is a mistake. I mean, I'm not accusing you of underestimating the problem. It isn't a big problem, but it is a sort of visionary project that can, in fact, make Pakistan proud of an achievement that needs to be solved, and needs to be solved by other deltas. You can do it.
Thank you very much for having the confidence and giving us the confidence that way, Roger. It was great talking to you, educating my audience on what it's about, subsidence, how important the deltas are, how important it is for us to have the confidence in our abilities, and also to find solutions and make an example for the world. And with that, we will end today's conversation with Professor Roger Williams. Thank you.